Hi, no jingle, no song. Just welcome aboard, everyone. Piecewise linear functions. Unit 3, lesson 6. Piecewise functions. So we have, let me get my pen set up here. Okay, so piecewise functions mean that you're looking at multiple equations for one graph. So we have a piecewise function here, f of x equals. This has two entries. Now, in the calculator, most of you know where this is located. So we're on the graph page, and you go to the right of the 9, and there is your piecewise function, and there it comes up. Okay, if it's more than 2, then you go to the 3. If it's 4, you can still do 4 as well. So I'm going to put this in. So there it is. It is in the graph. Make sure you know where the less than or equal to the less than signs are. Make sure it looks like exactly what you have. And then you go to your graph. So you just hit enter. So there's a snapshot. Well, that's the whole graph actually, because it's a piecewise function and it is a restricted domain. So they want us to fill the table out. So we're going to control T. They want us from -3 all the way up to 4. Okay, so here they are, -3 all the way up to 4. Okay, you can see it's undefined everywhere else. That's what U means, undefined. Okay, above 4 and below -3 because it is a restricted domain. So when you fill this in, we have values of -6, -5, -4, 4, 4.5, 5, 5.5, and 6. Okay, now the key thing you need to look at when you're doing these piecewise functions is where there is a break or a new graph. So it's going to start and go from -3 to 4. So 1, 2, 3. So it goes from -3 to 1, 2, 3, 4. And you can see that there is a 0 in the top and the bottom. So that is x equals 0. That's your y-axis right here. So you need to see what's going on to the left of that and to the right of that. So if I go ahead and graph this, -3, -6, so 1, 2, 3, 4, 5, 6. Okay, now be very careful because of the equal sign. That's a filled-in circle. I have -2, -5. I have -1, -4. And then watch what happens at 0. And at 0, I go up to 1, 2, 3, 4, way up here. Okay? And then 1 is 4.5, so 1 is 4.5. 2 is 5. 3 is 5.5. And 4 is 6. Okay? So I know that this part of the line looks like that. All right? And these are colored in because of the equal sign. Now, this here, too, is right there. Okay? But what you need to worry about is what's going on between 0 and -1, this portion here. Because every value should have an output. Every input value should have an output value. So in order to figure this out, this top graph goes up to 0 but does not include 0. So that means it includes -0.00000001. Okay, that is a member of this portion of the graph, this top portion right here. So I put 0 in for this x value. 0 minus 3 is -3. So I go down 1, 2, 3 to -3, and I put a circle. Okay, because that means that it is not included. All right, so that is your piecewise graph. And there's no arrows. No arrows because it's a restricted domain. All right, so there's your domain. State the range of f using interval notation. So the range of f. So my lowest value of f, meaning the y value, is -6. So -6, it goes from here to here because there's a break all in here. So -6 to -3. The -6 is included, the 3 is not included. That's why the 6 gets a parenthesis, the -3, I'm sorry, -6 gets a bracket, the -3 gets a parenthesis. Union. And then I pick up again here at 4 and go up to 6. both brackets there because they are inclusive. Right? Now, what happens sometimes is they will give you a graph, and then you have to figure out the piecewise function. And you have to be very careful because you cannot have two equal signs. Otherwise, you don't know which equation it goes into. Okay, so first thing we do is you can see that there's three parts to it. Okay, so we have three parts to it. So we have our f of x over here, and it's going to equal. So the three parts, I start 1, 2, 3, 4, 5, 6. It starts at -8. There's an x here, and it goes to -2. Then it goes from -2, another x, to 3. So this is the -8 to -2. This is the -2 to 3. And then I go from 3, x in the middle, down to, what is that, 6? That is 6. Okay? Now, the -8 is included, so it has to have the less than or equal to, as well as the 6 is included, so it has to have the less than or equal to. Now, it's totally, it can go either way. Okay? So I can have a less than here, and then a less than or equal to, less than or equal to. Because I don't want to have two equal signs at the -2 or the 3. Because if it's not a continuous graph, meaning it doesn't connect, then you could have two output values for the same input value. Therefore, it is not a function. Okay, so from this information now, we have to find the equations. So clearly they're all lines. So first thing, the easiest thing to find is the slope. So I start from here, and I go to a next point that is on one of the axes. So 1, 2, 3, 1, 2. So the slope is 3 over 2x. So you got the slope. Now, finding the y-intercept, it stops here at the -2. So just extend it. So I go 1, 2, 3, 1, 2. There's your y-intercept. And that's at 1, 2, 3, 4, 5, and that's at 7. 3x plus 7. And that is your first equation. The next one is just a constant. Okay, it's y equals 1, 2, 3, 4. Y equals 4. The next one, the slope again, okay, is down 2 over 1. So that's -2x. Okay, so now the slope, I have to go up and over. So down 2 over 1 is the same as going up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. So if this was 1, 2, 3, 4, 5, 6, 8, this is going to be 1, 2, 3, 4, 5, 6, 7. This is 8 up here. Okay, then there's another one here, and that's going to be 10. Plus 10. And those are your lines. Okay? They're all lines. Some could be quadratics, but the lines are easiest to find. Okay? And then we move on to, here's another piecewise equation. Consider the piecewise linear function. Determine the y-intercept. Okay, so the y-intercept of this function algebraically. So what that means is your y-intercept is where x equals 0. So you can go ahead, plug it in your graph, whatever else, but if they want to show it algebraically, you have to find which domain has x's equal to 0. So this top one here is x is less than 2. 2, 1, 0, -1, -2, and so on. This is greater than or equal to 2, so 2, 3, 4, 5, 6, 7. So that means this right here will include the y-intercept. So if I put 0 into that, determine the y-intercept is going to be 5. Okay? Because that's where you put the 0 in. Why can a function have only one y-intercept? Because if it has more than one, it's going to fail the vertical line test. So you can only have one y-intercept. So find the x-intercepts. So just like we found the y-intercepts, you put the 0 in for x. To find the x-intercept, you put the 0 in for y. So I have 5 minus x equals 0, and 1/2 x plus 2 equals 0. So this one is just easily x equals 5. And this one here is 1/2 x equals -2. Multiply both sides by 2. X equals -4. So those are my x-intercepts. Now graph the piecewise linear function. You could put it in your calculator and then see where all the coordinates are. I'm just going to go ahead and sketch it for you. So I am, and this is the key right here at this 2 right here. So that x 5 minus x is the same as negative x plus 5. So that means that the y-intercept is 1, 2, 3, 4, 5, and the slope is negative 1. And it doesn't include it. So that means that this is an open circle. Okay? So that's this part. Now, it's not restricted, so there's an arrow. Okay? Now, the next one is 1/2 x plus 2. So I'm going to find where 2 is. Okay, 2. All right, but I don't include this. All right, so this is the y-intercept, and then the slope is 1/2. So up 1 over 2. Now I color this in. Okay, it's the same point, so you color it in. Up 1 over 2, up 1 over 2. So it picks up from here and goes like that. Okay, you can put in your graph. It's perfectly fine. Okay, now it says, why does your graph contradict the answers you found in part B? So what does that mean? That means that there's no x-intercepts. So the contradiction is that the piecewise function doesn't include the intercepts, because the first one was at 5, 1, 2, 3, 4, so here, and the second one was at negative 4, 1, 2, 3, 4. Now, it is not included in my piecewise function. So that's why the x-intercepts exist, but not in this piecewise function. If I was just looking at a single line, then you would have an x-intercept, of course. Okay? And I kind of just answered E. In the last one, exercise 4, because I'm looking at my time, for the piecewise function, find all solutions to the equation f of x equals 1. Okay? So we want our f of x to equal 1. So that means we do look at both equations, and f of x is 1. Darn bug. So I have negative 2x plus 10 equals 1. Minus 10, I have a negative 2x equals negative 9. X equals 4.5. And that would be for the top equation. So you say, oh, is that a solution? It is hypothetically a solution, because if you put 4.5 into that, it's going to give you 1. But my domain restriction is x is less than or equal to 0. And 4.5 is not less than or equal to 0. So this one will not be in this linear function. When we look at the next one, we have 5x minus 1 equals 1, 5x equals 2, x equals 2/5. Okay, you put that in your calculator, of course, that is 0.4. So 0.4, if you look at the second one, x is greater than 0, 0.4 is greater than 0. Okay, so the solution is x equals 0.4, because it is in this piecewise function. So you got to remember, you're looking at a snapshot of each of these lines. We're starting with lines now. Like I said, it could be quadratics or other graphs, but for now it's just lines. Okay, I guess that's it. All right, well, I hope you enjoyed it. All right, yeah, I'll see you in class.